All right, so for part C of this section, so 2.6C, we're just going to finish up. So um, we're just going to do one more example. So we're going to find the rate of change in the angle of elevation. So angle of elevation of the camera means the camera's in the bottom left corner. It's recording this shuttle being launched. And as it goes from ground level up, the camera starts to pan up, right? So that's an angle of elevation whenever the angle opens in an upward direction. If the angle opens up in a downward direction, that's called the angle of depression. So we're looking for angle of elevation, okay? And they want to know what is the rate of change of that angle of elevation at 10 seconds after liftoff, okay? Um, so we have something being launched up. We know that the height that it's at is an S value. We know that the camera is 2,000 feet away from wherever the launch pad was. And of course, the camera has a distance to that ship, but they really don't label that for us. The theta is what we're interested in, right? So they said find the rate of change. Now, rate of change, that means what again? Derivative, right? We're trying to find the rate of change in the angle of elevation. So the angle is what? Theta, right? So what's the rate of change of the angle? How do I write that? D theta d what? T, right? It's always with respect to time. So find the rate of change in the angle of elevation of the camera at 10 seconds. So I'm going to say such that t equals 10. This is what I need to figure out. Now they gave us a little formula to use. Okay, it's just a definition of the picture that they gave us. They said, look, you have an opposite side and you have an adjacent side in your picture, and you have an angle of theta that you're looking at. So that looks like tangent, right? So tangent theta must be equal to S over 2,000. So what I'm going to do is I'm going to use that formula that they gave me, tangent of theta is equal to S over 2,000. And I'm going to take a derivative of it, okay? So when I take a derivative of tangent of theta, what do I get? All right, secant squared theta d theta dt, right? Because I took a derivative of a function with theta, right? Not a t. Now, S over 2,000. Now, you guys got to understand that's 1 over 2,000 times S, right? So we do have a constant of 1 over 2,000. What is the derivative of S? It's 1 what? Yeah, ds dt, right? So 1 ds dt. So that's what we end up with our derivative. Now, if we look a little closer at the information they gave us, okay, which I just kind of noticed that I forgot to put on here, they did give us a function to start with, just so you know, okay? The function wasn't important up until now, so let me show you what it is. They said that this function for this spaceship is s equal to 50 t squared. Okay? So I want to find d theta dt. Okay, that's my goal. But I have a ds dt. Excuse me. What is ds dt? Yeah, it's how fast the height is changing. Now they gave me a function that tells me height. Height is 50t squared. So if I want to find ds dt and they gave me s, what should I do? Take the derivative, right? So let's take the derivative of s. ds dt is equal to 50 times 2, that's 100 t. So I can now plug in that information into ds dt. Now I can reduce 100 and 2,000, right? I can get rid of 2 zeros there. So just to clean it up a little bit here, I'm going to divide both sides by secant squared theta. So this is what I end up with. D theta dt is equal to 1, let me write it this way, 1 over, actually, t over 20 secant squared theta. Are you guys with me so far? Anybody not too sure what's going on?
Wouldn't it just be t over 20 over x to the theta, or can you just do it?
Well, yeah, it'll be over, but then when you reduce it, you got to flip the division, so it becomes part of the denominator anyway.
Oh,
Now, secant squared theta on the bottom is really what, if I move it up? Yeah, that would be t cosine squared theta. Now, here's the thing. I need to figure out two things, right? What is cosine of theta? And then I got to square it. And what is t? Now, I do know what t is. D theta dt when t equals 10, well, that's going to be 10 cosine squared theta over 20. So notice I'm just left with the following. Cosine squared theta over 2. So what is cosine squared theta? Well, here you go. This is how you're going to figure it out. We have a triangle that looks like this. We know this is 2,000. Okay? We have a formula that tells us the height. When t equals 10, what is my height?
5,000.
So yeah, it's going to be 5,000, right? So let me erase this. Now, if I'm trying to figure out cosine, don't I need to know adjacent over hypotenuse? Right? I don't know my hypotenuse yet, but it's going to be 2,000 squared plus 5,000 squared, and then I got to take the square root of that. Okay? So let me plug that into this problem here. So cosine of theta, now remember I got to square it. Cosine of theta is 2,000 over this, right? So 2,000 over the square root of 2,000 squared plus 5,000 squared. All of that squared divided by 2. I know this is getting kind of messy, but this is where you're going to use your, how would they say that in Blue's Clues, your handy dandy calculator, right? And start simplifying. So if you put this into your calculator, you get, well, let me see if I can clean it up a bit. 2,000 squared over 2,000 squared plus 5,000 squared times 2. That's what it becomes, a little bit more cleaned up. That 2 doesn't look too obvious there. So here's a nice thing. Once you're done doing the cleanup, you end up with 2 over 29. What are my units? Remember, this is d theta dt. So what is my unit for the angle? Did they mention that it's degrees? No, right? They never mentioned degrees. So if they don't mention degrees, then use radians. Because normally radians is the preferred measurement. In terms of time, what did we use in the picture? Feet, right? Feet, and they said at 10 seconds. So that's going to be seconds. So this will be radians per second. This is my answer for that problem. So that's this example. If you guys have any questions right now, we can talk about that. But I'm just going to stop recording it so you guys don't have to